We shall begin. So this is Module 4. Ang Module 4 class, we're going to talk about Newton's laws and dynamics. Okay, let's start with this. So we encounter forces in our daily life, of course. Ang push and pull by the gravitational force or ang actual na external force by your colleagues na i-push ka or i-pull ka. Lifting objects. These are quite visible. Ang mga observable siya with our observable siya with our by visual lang siya, visual inspection. But there are things na like invisible, like kaning electromagnetism. So we cannot see ang push and pull of charges because of wavelength niya, wavelength sizes. I assume wavelength sizes. Okay? But these are forces that we generally encounter in your daily life. And forces is of course is a vector quantity. That means na siya ay, again, magnitude and direction. So generally, forces is denoted by F. Okay? Rema, hilig mang-recycle ang physics sa lahi ng mga symbols like F. Okay? So the unit of force is newtons. So 1 newton is equal to 1 kilogram meter per second squared. So if you look at the units na kilogram meter per second squared, na siya ang kilogram talks about mass and meter per second squared talks about acceleration. Okay? Acceleration siya. So if you imagine a rigid body, like this one here. Choose green. Like this one, this rigid body here. So it is interacted by 4 forces. As you can see, the 4 forces are oriented differently with respect to some axes. But this can be summed into a singular force, which you call the summary of force niya. So of course, if you look at F1, F3, F4, they're like almost in opposite, but they're not completely in opposite. So what we do is that if you remember sa module 1 is that you obtain the forces along x and forces along y. Then you can sum the forces along x and forces along y. So generally you can write the sum of force F as the sum of force equal to F1, F2, F3, F4. So this is in vector na form. But you can also break it down into sum of forces along x, sum of forces along y. Okay? So okay, with that, masum up man mo. Unlike kaning ko, ang general na form, you cannot directly sum ang F1, F2, and F3 because they're not necessarily lying on the same plane. But in two-dimensional class, you can of course divide them into the forces along x and forces along y, which makes it easy to sum. Newton's 3 laws of motion. So, these laws relate force to acceleration, motion, and mass of the body. These laws allows us to predict motion of a certain system. But of course, this is referring to scale. Okay, kung dako na objects, it might be predictable pa siya. But yung subatomic, lahi po check behavior dito. So, wanang mo-appear ang mga term na relativistic na motion. But here, Newtonian pa ta. So, it's fine. So, the first law is the law of inertia. What is inertia? So, a body at rest will remain at rest unless acted upon by an external force. Okay? This inertia. So, the tendency of a body to resist motion or change in motion. Okay? If it's initially at rest, di siya mo change ang iyahang position kung dili siya i-push. In motion po, di po siya mo change ang iyahang nature which is in motion unless na mo stop niya the external force mo. So the greater the mass of an object, the greater is its inertia. And the greater is the force needed to accelerate it. So, like for example, if you're trying to move a cabinet na walay wheels, na let's say ang small cabinet, o mas dali siya i-move, small cabinet, let's say 1/2 lang sa imong weight. Unlike sa kanang cabinet na let's say twice sa imong weight, it requires more force to move it. So if we assume that these are identical ang kaning push sa ilaha, then ang nag-differ lang is that ang ilang gina-push. The first image naga-push siya baby, and the other one is naga-push siya og katong mama. Okay? So as you can see, mas paspas i-push ang gagmay na mga objects. So Newton's law of motion or law of force and acceleration is mathematically represented as the sum of the forces is equal to the mass or proportional to the mass and acceleration. Okay? If the mass is large, the force is large. If the acceleration is small, ang force put is small. Okay? So net external force. When we say net force, we're actually referring to the net external force because as you know, ang particles inside of an object napod sila physical quantities like kanang electromagnetic, kanang interaction sa imuhang atom to atom, ana. So however, these are ignored na forces kanang internal na forces. Ang gina-consider lang diri is kaning mga blue arrows, blue thick arrows, the external forces. The internal forces are typically ignored. Okay? The next one is Newton's third law or the law of action and reaction. As you can see na ay naligo dira nag-swimming. Of course, if mag-swimming ka, you tend to stride against the water. So it's an action reaction form. So pag stride niya ha, iyang gina bring down ang water paubos ang body, thus allowing it to propel himself to a direction na iyang gusto. So whenever a body exerts a force on a second body, the second body exerts a force back. So meaning the water exerts a force in opposite to the force exerted on it. Okay? Thus pushing it to a direction. So why do you feel yourself being pushed back to the seat in an airplane on takeoff? Okay? Anyone? Anyone? Oral lang sa tagay, wala ko tayo. Shall I? Ah, Noemi, donde yan has raised her hands. Noemi,
Yes po.
why?
Because your body is trying to resist the change po. So the inertia is trying to resist the change.
Mm-hmm. Yeah, that's right. It's trying to resist the body. The 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 person on the plane is actually a different body compared to the plane itself. Okay? As it moves, of course, kung let's say dili siya attached to the plane, what happens is that when there's a sudden change niya, ang plane pa forward, siya actually is somewhat pa backward kay nabilin na siya. Okay? So, same gyapon ang hitabo kung let's say suddenly mo stop ang plane. Ang passenger will just continue on moving. Just continue on moving kay mo man ang nahitabo sa sayang action reaction. Okay?
Mm-mm.
Resume. Okay, resume. So, I guess you're familiar with this one, ang free body diagram. Technique ni siya to make a bit complex nga problem into simply arrows on a coordinate system. On your left is a block mass na naay upat ka forces. The first one is ang nasa block, which is the weight. Then you have external forces. Weight is a force because na siya mass times it's lying on, let's say, a surface and a gravitational acceleration. Then you have mass times g equals to that force. Then you have the external forces. So it's lying on a surface. Ang surface, sa action reaction would tend to exert a force against the black mass. So manong tawag na to na normal force. Then you have an external force, F. The F there could be someone pushing it. So, manang external force F. Then, ang surface pod, na siya'y force along the surface, which is the friction. So the friction would tend to resist the motion. Yeah, it goes against the direction of flow. So if imo siyang i-simplify, you put these four forces into the Cartesian coordinate system, then you simply connect ang ilang mga tails to the origin, then you have the normal force pasaka, the weight pababa, then you have the friction going to the left, and force F going to the right. So this is how you simplify a problem like a block of mass is being pushed on a surface and high friction. Okay, it's simply reduced to this figure on the right as arrows. Okay, next. These are the common types of forces. Weight, normal force, which is perpendicular to the surface. Then you have the friction, which lies on the surface. You have the tension. Okay, these are the common Opatka forces. And of course, since forces sila, they're all in newtons, kilogram meter per second squared. Weight, defined to be the force of gravity on an object, it is also location dependent. So, if you're at different locations sa Earth, na siya'y gamay na discrepancy sa value sa gravitational acceleration. Okay? Gamay lang. Pero, if you compare nimo, if naka sa Moon o naka sa Earth, ang weight nimo would be different. You would feel lighter sa Moon. Hence, kanang mga astronauts, kung maglakaw sila mo siya marapit mag-ambak-ambak. Okay? Okay. And you also have the concept of center of gravity and center of mass. Center of gravity depends on both mass distribution and gravitational field. In a non-uniform gravitational field, the center of gravity and the center of mass are the same. Okay? Uniform siya. In non-uniform gravitational field may differ. Okay? Sa Earth is actually nagiging variation sa gravitational acceleration at different locations. Okay. Next one is ang center of mass. It depends only on the distribution of mass. It is geometric property of an object. So, geometric property, if you have like a block, most likely nasa tunga ang iyang center of mass. It remains the same regardless of the object's orientation or location in space. It can lie outside the physical body, such as kanang kuan, Dunkin' Donuts or donuts. Ang iyang center of mass nasa gawas nasa tunga, which is in an empty space. So here we have different center of mass or center of gravity. So you have for symmetrical objects, you have the center of mass there. Okay, so like a cube nasa tunga, for a sphere nasa tunga. For non-symmetrical objects like for people, generally ang mga babae ang center of mass or center of gravity is nasa lower half, a bit lower. While sa lalaki, a bit nasa taas. Okay? Here we have normal force. Normal force is perpendicular force exerted by the surface to an object resting on it. Like kani siyang block. Ang block na siya sa flat na surface. So ang normal force ni Moha is of course this one here. Ang relationship niya with the surface that it's 90 degrees. 90 degrees siya. Ang symbol niya is N. So good nagka-confuse ano niya kay ang value po, ang symbol po sa newtons is N. So, hi. In a horizontal surface, the normal force acting on an object resting on the surface is equal to the object's weight in magnitude but opposite in direction. So, kung let's say wala naga-move ang imuhang blocks kanina sa table, not moving specifically upward or downward, ang normal force is equal to the weight of the object. Okay? They cancel each other out. So if you know the weight, then you can know the normal force for this case. Okay. Next. Friction force. Friction force results from physical contact between two surfaces. Okay. The first type is the kinetic friction, and the second type is static friction. From the word, kanisa number one, kinetic meaning it is in motion. While static is wala, masyadong stagnant. Okay? So two different frictions. So, for example, sa kinetic friction is ang kanang mga moving objects, mga bus, mga so on, nagadagan. Ang static would be like kanang object na ibutang nimo sa lang, sa salog or non non-moving na mga objects. So they're having a static friction. So kinetic friction, ang force niya is associated with uh, moving objects on a surface. Like for example, kaning sa upper ni mo ha, na kay block, kani siya, and na ay naga-push niya ha. So ang motion niya goes in the same direction as the pushing force. Since ang surface niya na friction, it tends to behave that it goes against the pushing force. Okay. So ang symbol niya class is small f subscript k, k for kinetic, is equal to mu k times the normal. N is a normal force. Mu k is a proportion value. Depende sa relation sa material A and material B. It is calculated. It's measured. Okay. So next one is the static friction. So the static friction, as you can see, it is a friction related to objects that are at rest while in contact. So while kanang sa figure sa upper left, na nag-push niya na force, ang counter sa iya is ang friction. What happens is that, of course, wala motion. So zero na siya dira yung motion niya. So if we have here, ang expression niya would be Fs is equal to mu s times the normal. So they're just the same, except lang ang subscript is S for static. Normal gyapon ang N. I mean, like, not normal. Ang N symbolizes a normal force. Now let's compare. Let's compare ang duha ka friction. So sorry guys. What's up, 2D? So let's look at kinetic or static friction on the same types of surface, except na lang a bit gamay na variation. Like the first row is rubber on dry concrete. So kung it is moving, ang iyahang ang coefficient of kinetic friction is 0.7. When it is static, 1. Then you will see a pattern here na ang mga static na coefficient, they're all greater than the kinetic. What's going on? And ay couple of them that are identical. But generally, ang trend niya is that ang static has a larger coefficient than the kinetic. Okay? So it simply means na it requires a lot of energy to move an object that is initially at rest. Pero once it is moving, gamay na lang kag-effort. I think maobserbahan niyo ka ng, let's say, push mo ref. Kung hindi niyo kaya ang ref, something else na ma-relate niyo. Initially, taas yung energy na require. Mag-push yung table. So, initially, taas ang energy requirement mo para ma-overcome ang kanang static friction. Once it starts to move, then it becomes a kinetic na friction. And this is generally mao ni ang iyahang trend. Okay? Nayoban identical. Like Teflon on steel. Yung kinetic or static are identical. Okay, guys. Now let's consider a rectangular block with mass of 2 kilograms na mass and width of 4 meters and length na 8 meters, sliding on a surface with constant velocity. Which position produces greater kinetic friction and why? Okay, mo naman si Noemi. Anyone else? Anyone? Jane has left the meeting. Why? Where you go, Jane? Uh, nawala ang slide. Nawala ang slide? No, I mean like I'm asking this question. Kita niyo yung slide, class?
Yes po.
Yeah, I'm asking this question. Which position, which position produce greater kinetic friction?
Mm,
Which one, class? If anyone? Which of the two positions produces greater kinetic friction?
Ah, siguro sir kay the same ra sila sir.
Cherry, is that you?
Yes sir.
The same ra sila? Why? Why is that, Cherry?
Kay kuan sir, the same raman ang ilahang mass nila sir then. Although ang isa kay kanang upright ang iyang position pero the same raman lang mass. So I think parehas ra sila.
Yeah. It appears na because the expression for the kinetic friction is just mu k times the normal. And the normal is just dependent on the mass. For this case, the normal is in the opposite of the weight. So mg ra na siya. So regardless sa iyahang surface interaction, it's only dependent on the mass here for this case. I don't know if kuha ni siya, ma-challenge pa ni siya. I think ma-challenge pa ni siya. Pero mathematically, it tells you that one. Okay. Maybe you can try sa inyong mga schools experimenting on this one. Next one is ang tension. Tension, this comes from the Latin word to stretch thin. So in the figure na kay bucket on a rope, of course, it's not just ang handle sa bucket na ka-experience of tension, it's also the rope. And the next image is na kay muscle. So muscle being contracted. So ang muscle nag-experience of tension. So this force is usually observed when a load hanged using a string, rope, cable, and chains. The symbol niya is T or in some cases FT, F subscript T. Okay. Origin of forces. Nakay origin of forces here. One is gravitational force. Next one, example ana is ang weight. This is produced due to the force exerted by the gravity to a body. Second one is the electromagnetic wave. Ang friction is the interaction of the molecules. So electromagnetic siya. Okay, then also tension. This is produced due to the cohesive atomic and molecular electromagnetic forces acting on the string. So essentially, ang mga bonding niya, chemical bonding. Okay, these are the two sources of origin of forces. Oh, that's it. Okay. So, any questions before we move to the next module? Actually, may example pa din. Sorry, class. But so far, any questions? Nan? Nay, nay?
None so
Nana?
far, sir.
Wala pa, sir.
Wala pa. Nay, nasabtan? Wala pa.
Nakasabot ra pod, sir.
Yes, sir.
Okay, good, good. Let me look at some examples, class. I want to show you guys something. Kani siya. Kaning free body diagram. Some figures here. So here are some way of drawing a free body diagram. Like for example, this one. This. Yeah. For example, this one. The free body diagram is quite familiar because a block of mass lying on a surface with a friction F is pushed by an external force F and moves towards east with acceleration A. So to do that one, so of course nakay force here para sa imong F external. Then you have the weight. Then naman kay surface, perpendicular to that surface would be the normal force. So it should look something like, of course, ang acceleration, di na to siya butang dira kay acceleration. Ang unit niya, dimension niya is meter per second squared. Pero ang normal force, ang weight og ang external force is in newtons. So it should look something, not a step 1. So external force, friction, not by friction. Did it say na friction? Now with friction, so not by friction dili diagnose. Sorry, mapasa like that. So now kay F external force, then you have the frictional force, then you have the normal force, and lastly, ang iyahang weight. So once you simplify this into the free body diagram, it would look something like this one. Okay? Ibutang na nato asa sila na axis ng butang. So of course, ang normal ug ang weight, they're moving up and down. So for this case lang klasa kay posible mangutsad na skewed ang surface, so malahi ang iyahang direction. But for this case, it's a block lying on a surface under friction or being pushed. Ang normal ug ang weight, they're just along the y-axis. Ang friction ug ang external force is along the x-axis. Okay? Let's move. This one. So, nakay mass na ni-slide sa isa ka curve na track. Okay? Na-hint diri, negligible ang friction. So, essentially, wala friction. So, to do that one, we identify the forces. Nakay normal force. This normal force is perpendicular to the surface. At that particular point, na perpendicular na force dira, which is the normal. Next is ang gravitation. Ang gravitation, ang weight niya is always going downward. Next is ang, we reduce the block to a point, identify the best relative positions, and thus you have this one. So, mani ang FBD. Ang normal niya is not in the opposite side sa iyang weight. Sa kadtong nga position kay na siya on the perpendicular of the curve. So the next one is like this. Same thing, pero this time na siya sa mid. Na siya velocity. So again, we identify the forces na kay friction, or in this case, na friction. Na friction ni siya kato ganina wala. Then you have the normal, which is perpendicular to the surface. Then you have the weight. Then, simplifying, we get this. So, gibutang nato ang normal along the y-axis o ang friction na sa x-axis. Pero ang weight ni mo lies neither on the x or y. Nasya sa in-between. So, that means, to solve this one, you have to break this one sa component. Nasya weight along y. Then you have weight along x. So just simply sum the forces along the x and along the y. Okay. Oh yeah, like I said. Next is kanisha. So nakay duha ka block. Actually, napay pulley. For this case, pulley is this one class. A block of mass M1 and M2 are connected in a string of negligible mass lying on an inclined plane with no friction. Okay, the string is run on a frictionless pulley. as the system favors M2 as the heavier object. So mas mugat ng M2. So most likely, mas slide siya pa na. Take note, frictionless pulley. So wala siya friction dira. So dili siya mo rotate ang pulley ni mo ha. Step is to identify the forces present. So as you can predict, duha ka buok ang imuhang free body diagram. One for each mass in this case. So na kay normal 1 ug normal 2. They are both perpendicular to the surface where naglay ang imuhang blocks. Then you have weight 1 and weight 2 kay naman siya mass. Then you have the presence of tension in the string. Okay. Now, ang tension in the string is denoted by T, and they're both moving in the opposite direction. Okay, of course, sa M1, iyang ginabira pataas ang imuhang block. Sa M2, iyang ginapungan ang mass 2 to slide down. Mo ang purpose sa iyang tension. Second step is to reduce the block. So, reduce the block into a tiny block. So reduce the block to points. Then we align the forces. So as you can see, mo ni siya ang naong sa imuhang duha ka free body diagram, one for each mass. Okay? Of course, we then break down into components ang mga forces na wala naglay sa either x or y axis. So, simply ang mong weight. Okay, weight 1x or weight 2x or weight 1y and weight 2. Very simple. Okay. Can you correct those? Next is Kani. So you have a block of mass M1 and M2 connected by a string on a negligible mass. Mass M1 is lying on the table plane with friction, while M2 is hanging on the side of the table as shown in the figure. The string is run on a frictionless pulley, so the system favors M2 as the heavier object. So meaning bukat ang M2 and it appears to be moving downwards. So we have identify the forces present. Normal force kay na kay surface. At of course, napod kay weight 1 and weight 2. So wala siya yung normal force 2 because wala man siya surface dira. Pero na sila'y tension. So for M1 ang tension, ginabira niya pasulod well ang tension. The other tension, ang direction niya is ginabira niya pataas. Okay. So the surface has friction, finally, and then you reduce them into tiny points. Okay. And this is, it should give you something like this. And you have three body diagrams. Okay.
The end for now. More questions.
Okay. Okay. Any questions about sa pagbuhat o ka ng three body diagram? Thanks, Jules. Dapat na nasabtan na kaya na. So, nalagyan eh. Let me check again.
Here we have. The first step is we draw an FB.
Sorry, klase. Let me present this. Okay. 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 So we have here module 4 again, problems on force examples. So in this problem, you have duha ka mass M1 and M2 connected by a massless rope hung over a frictionless nga pulley. So, shown on the figure. After the masses are released, calculate the downward acceleration of M2. So, ipaboran niya isang M2 paubos, ang M1 is pataas. So, na kay duha ka masses, so you would expect na duha ka free body diagram. Okay? Siguro kung nag-rotate pa ang kuan later sa torque na, we will include ang pulling system. But for this case, frictionless pa siya. So M2 here is greater than M1. As you can see, the magnitude of the acceleration are the same. Ang ilan lang direction ang opposite. So, first case is kani siya. For M1, you have acceleration going upward. Ang tension 1 mo is just the T1 going upward minus weight 1 paubos. Ang imuhang next is ang imuhang for M2. Sa M2 nimo ang imong tension is still going upward. Prevent niya kasi the opposite sa kuan. Sa mass, opposite sa. Then nakay weight 2 paubos. Ang acceleration nimo is negative A, so since it's going downward. Okay. Okay. For M1, we sum the forces along the X. Along the X, wala man. So, 0 na siya. Kaya wala may forces disturbing it from X. But sa sum of forces along Y, you have tension pataas, so T, minus the weight 1, paubos, is equal to M1A. Okay? Di man siya at rest, so it's moving. So, ang tension mo is an expression of M1A plus weight 1. Okay? Weight 1 is, of course, M1G. Constant G. The next one is among free body diagram for mass M2. So, M2 is going downward. That's why negative ang acceleration. So, we do the same class. So, we sum the forces along X. Here, wala man siya forces along X, so it's 0. Along Y, you have tension pataas o weight 2 paubos. So, it's equal to negative M2A, meaning nipabor ang downward. So, M2A is equal to weight 2 minus T. Oh, weird. Weird yung arrangement. Pero there's a purpose. Let's look at nga nung known niya. It doesn't really matter kaya depende man sa question. So, M2A, weight 2, minus 1. Ang imuhang gibuhatan ni class is that i-substitute ang value sa tension onto the expression. Okay? So, M2A is equal to weight 2 minus M1A plus weight 1, which is T here. Then we group like terms. So, na-dre sa left side ang mga M2 o M1, then sa right side ang W2 minus W1. Okay? So, rewriting, you get a proportion expression. A is equal to this. Okay. Finally, ang acceleration niya is given as a ratio of gravity, the difference of M2 minus M1 over the sum of M2 plus M1. Okay. 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 Any question, class? Some examples. Any confusion? Walay Confucianism? Hello?
Wala pa, sir.
Again, wala. Wala pa.
Hi,
Same
sir.
with
Excuse me, sir.
Yes. Kisa to?
Ako,
Yeah,
sir,
Pat.
si Patrick, sir.
Yes.
Kasi kung gani, sir, ano ganito na kuan siya, sir. Kato bitong with respect to y. Ano gito siya na equal, gito siya sa equals M1A or kato sa PCAS po, sir, M1, ay M2A po siya, sir.
Let me check again. Itong sa ikaduha na example,
Katong bago lang, sir.
atong bago lang.
Yes, sir.
Let me check. Wait. No, Mati kudasai. Nalang magipang-delete ang mga audio kay nakoy audio mo gudani. Kanto siya yaw-yaw iya. Wait lang. Wait lang po. In a minute. Kabing mainit. Da-da-da. Da-da-da. Okay. Okay, ma'am. Kani siya, Pat? Kani? Kani nga problem, right? Hello?
Yes, sir. Mo na siya, sir.
Ang question mo is nga no,
Ngano sa kuan, sir, ba? Katong iyang summation of M, kana siya, sir, ba?
ah,
Ngano dito siya equal sa M mass 1 times acceleration ang kaning sum of all forces relative to y.
okay. Sa W1 or W2?
Parehas naman sila, sir. Ang kuan lang, sir. Pili lang para sa duha, sir, pero ang sa kuan daw, sir, sa M1 daw, sir.
Sa M1?
Yes, sir.
Sa second equation?
Yes, sir.
If you look at sa second equation, your question is nganong dili sila the same?
No, sir, ngano sila, ay, dili, sir, ba? I mean, ngano ang force relative to y, sir, kay ang equal niya kay M1A sa mass 1 ug ang sa PCAS pud kay M2A
Pero negative.
o negative kay
Yeah.
downward man siya.
That's right. Kay ang sa mass 1 or ang weight 1, ang object, ang block is going upward. So positive ang iyahang direction kay force
Yes,
man.
sir.
So its tension, the tension is still going upward kaya gina-prevent niya na mahulog ang weight 1. Sa scenario sa mass 2 is actually the same. Same gyapon nilang behavior sa iyang tension. Gina-prevent niya ang weight 2 from moving too fast downward siguro for this case. But ang net niya na acceleration, ang net niya na force is going downward. Kana ba? Did I answer that question?
So I mean, sir, ang meaning di ani, sir, kay force relative to y-axis, sir, ang ending ra niya, sir, ang summation niya, sir, is just the weight, sir.
What do you mean? Ang summation?
Bala pag naa siya tension, sir, ba?
Oh. Ang summation is just the weight? No. Ang summation niya is the difference or sum sa duha ka forces on that axis. So imong tension here pasaka man, so positive T. Then ang
Mm-mm.
weight 1 nimo paubos, negative siya. Then ang overall din niya na direction is going upward, so positive M1A siya. Ano siya? Ang
Mm-mm.
convention na value. Did I answer the question?
Yes, sir. Thank you, sir.
Okay. Anong pat ba? Base okay na lang. Okay. Actually, napalilain example eh. The next one is kani. You have duha ka blocks, but this time they are along an inclined plane. On the left is ang 10 kilograms na mass A na inclined at 30 degrees. On the right is mass B na unknown, 45 degrees. Two blocks A and B are lying on a frictionless surface. Okay, good. Shown on the figure are connected by a cord passing through a small frictionless pulley. Letter A, draw an FBD for each block. Letter B, calculate the mass of block B, which slides down the plane that keeps the system moving at constant speed. Constant speed plus ha. Neglect the mass of the pulley and the cord. So, panaog siya. Panaog siya sa here sa B. Sorry. Pana siya class. Pana yung direction. Okay? So, let's start. So, draw an FBD. Duha ka masses, frictionless ang pulley, frictionless ang surface, and nakay duha ka free body diagram. So, the first one is for MA10. MA 10 kilograms. So, ang imuhang x-axis, we consider the x-axis to be the inclined plane na may 30 degrees incline. Ang y-axis would be perpendicular to that plane. So, mao ni siya. Okay. If we examine, ang tension ni Muha will be coming from the string. So, paano naman ang tension ni Muha diri? Pasaka siya. So, hence, it's lying on the x-axis. Pasaka po siya. Then you have the normal force. The normal force, ang rule niya is always perpendicular to the surface. So, hence, ang imuhang normal force is this one, perpendicular to the surface, which we considered as the x-axis. Then you have the weight. Ang weight mo, wala siya sa y-axis here, but rather, patagak lang siya going straight to the core, bali. So, money siya ang weight ni mo na direction. So, the other two ka-weights here are just the components of the weight A, WAX or WAY, which you can calculate using sine and cosine, and sine and cosine of this angle, so that we can sum the forces now along the x and along the y. Similarly, we do the same with mass B. Okay, mass B. So 45 degrees from here, the incline will be used as the x-axis. So we use the positive x-axis kaning pa downward here. Lagi siya pa downward, pa incline up, pa incline pa baba. So you have the tension pasaka, this is the tension here. Kaya gina-prevent niya na mo fall ang imuhang block, dali-dali. Then you have the normal force perpendicular to the surface. So mao ni siya NB. Then you have the weight. The weight is of course matagak lang siya. So it's this one. Then di man nato ni siya magamit kay it's lying neither on the x or y-axis. We have to use its components, WBY or WBX. And we use the trigonometric function to solve for those values. Dali naman class kay na naman kay angle o na naman kay value sa magnitude na WB. Okay. And next is condition. We then write the sum of forces along the x and along the y. Di siya lisod, kuti lang. It takes a lot of time. So you have the forces along x. The forces along x for this one. Kanilang sa siya. Isolate na to siya. You have tension pataas, so positive or going towards the positive x-axis. Atong giset. Then you have weight x countering ang imuhang tension is equal to positive MA sa M subscript A. Okay, MA. But, nganong zero man na siya? It's because, mention kaganina, ang velocity is constant according to the problem. No? Move siya constant. So, the change in velocity, if they're the same, that's zero. So, 0 over time is just 0. So, mo siya, kani siya, constant na siya. So, we set this one into 0, ang kaninga side. Right side. So, that will be for fxa. The next one is ang imuhang FYA. Ang imong FYA is along the y-axis. In this case, mo ni siyang y-axis na tuwa. So, the normal A minus weight AY na pababa in this scenario is equal to 0. 0 siya kaya wala man siya nag-oscillate along this y-axis. So, we then apply ang cosine function to obtain the value of weight AY in terms of the magnitude weight A times the angle. Okay? That is for the mass MA. Next is for the mass MB, which is unknown ang imong mass. So we do the same. So you have tension plus WBX plus equal to plus MBA. And again, connected naman sila and they're moving at constant speed. So acceleration is 0, so ma-0 na siya. So tension minus WB sine theta B. So you have for the sum of forces along X. The next one is the sum of forces along the y-axis. Sa y-axis ni mo you have normal force B. Normal force B, it's this one going upward in this scenario, countered by WBY na pababa or going to the negative y-axis. 0 gyapon siya because it's not oscillating along this axis here sa y-axis. So NB minus WB is equal to theta B and WB is just MBG equal to 0. Okay. Now, to calculate the mass of block B, which slides down the plane that keeps the system moving at constant speed, we neglect the mass of the pulley and the cord. So, that means ang tension ni Moha is just MAG sine theta A. So, tension is also equal to, if gikan sa katong mass B na known is equal to MBG sine theta B equal to 0. But we know that earlier ang tension is this one. So substituting here, we get this expression. Then we transpose it on the other side ang second term. So we have this one. We have this one class. Then we rewrite it into expression into MBK. In this case, ang mabili naman ng good is ang MA. Ang you can transpose MB on this side. Then we can cancel out ang mga G ni Moha. Sila kayo present on both terms. Okay. So after that one, after eliminating G, so you're left with 10 kilograms sine 30, which is 0.5, or divided by sine 45, which is 0.71. So 10 kilograms times 0.5 divided by 0.7. And you're left with an MB, a mass B of 7.04 kilograms. In terms of mass, mas gaan siya. Pero, it's the incline. It's the incline naka-add, contribute siya. So, what is the tension in the cord? So, we can either use ang katong M sa MA or sa MB. So, if we're using sa MB, we can use this by substituting the value of gravity here, 9.8, and the angle, 45 degrees, and the mass of B. And you are left with around 48.71 newtons. What else?
For letter D, the problem introduces the
Sorry.
presence.
Sorry, class. Ay, kalimutan ko. Delete. Okay. So draw the FBD for each one. This one is with friction. So, we note that ang imuhang motion sa imong block is going, for MA is going upward. Okay, it's going upward. So that means ang friction mo, for this case, ang kinetic friction is going downward. Iyang i-counter ang dagan sa imong block, which is mo gina ang behavior sa mga friction. Manghilig mong oppose. So that is for MA. For MB, same thing. Pababa man ang mass B, iyang i-prevent ang pagpaspas ng pagbaba niya. So iyang direction is here. Siya sa opposite. Just an opposite direction. Sorry. Nasa sa opposite na direction. Prevent man niya ang pagbaba sa imuhang mass. Okay? So with the presence of friction now, itong kaganina wala man. So the equation changes. So for this case, ang F for MA, so Fxa tension minus AX because pababa man siya, padulong siya sa negative x-axis minus the coefficient, minus the kinetic friction A. K is equal to MA. Again, zero gihapon siya ang kaning right-hand side because constant man gid daw gihapon ang dagan sa imuhang block. So you are left with this a bit longer na expression because there's an addition of the friction here. Next is ang imong FYA. So essentially the same ba siya kay ang friction only interacts along the x-axis or along the surface. So you have NA is equal to MAG cosine theta. For B, again, mautro ang imong FXB because of the addition of the friction nga term. But then again, ang imuhang sa right-hand side, ang assumption is that nagdagan siya at constant velocity, so acceleration is zero. So you're left with is this expression here. And ang sa y-axis, identical. Identical ka, wala may friction. Again, same reason, wala friction nila. Next is to calculate the mass of block B using this time with a friction there. So a bit tasha because na may additional terms. But essentially you have the expression for the tension here. Okay. However, we don't know ang kaniyang NA. But from the y-axis, we are able to obtain this. We just simply substitute this term into the equation. The equation is. So you are left with this term here that is equal to zero. This term here. The tension expression is MAG sine theta A plus UK cosine theta. And for the other block, MB, do the same. Substitute this expression here to the normal force B here. And then you get this. Then you factor out MBG. After factoring out MBG, you have equating. Wait. Then you equate the two expression for the tension. Kanisha, tension man siya, tension po siya. So you have MAG sine theta A, UK cosine theta A, equated to MBG sine theta B plus UK cosine theta B. Rewriting the expression, you get a general expression for MB and substituting the values. Do not forget to put your calculator in degree mode but in our case, di na tayo magamit ng calculator. So you get the value of 7.91 kilograms. Very close lang. Okay.
Here we have a sample problem for Module 4.
Sorry, class. Wait, let's ask some questions. So any questions, guys? Any question? Was it na-follow rin? Medyo konti lang siya. Ah, Naimi? Ale,
Hello,
good.
sir.
Yeah, hello.
Dito, pwede mabalik tong slide, sir, katong nabitaw free body diagram, sir. Mangutana ko about sa angle.
Sa angle?
Opo. When kana po,
Kani?
kana silang, oo po, kanang unsa imong indication, sir, or ikaw ray magbuot kinsa unsa nga angle imong gamiton, or paunsa siya determine nga 30 degrees sa theta A, sa B kay 45 degrees, sir.
Kung ano sila, norms, they're given. Given siya sa problem.
Okay. So mag-base na lang ko. Okay.
Given siya sa problem. Dili siya unknown, bali. It's just given sa problem.
Okay.
Pero kapag kung
Okay.
anong na ang 30 degrees, sorry. Kabalo ka ang 30 degrees nga naa dire kay naa na siya dire. Anong naa na siya dira? Do you know that?
Katong sa triangle nga kuan, sir.
Oh yeah, that's right. Okay. Kung 30 na siya, this
Opo.
one is 90.
Opo.
Pila man eh?
That is 90? Ay, no. 60?
60.
Opo.
And eventually, you'll arrive kung kani siya right triangle man eh.
Opo. Okay.
90 minus 60 is 30. Manang 30 siya.
Okay. So akong question di ay, sir, nganong dili siya didto nag-start sa kanibitang with respect to x, sir? Nganong didto ko sa y?
What do you mean?
Sa angle. Kato lang, sir, na-confuse lang ko. Nganong dili siya with respect sa x? Di ba, sir,
Sa
kanang
x-axis?
weight? Opo.
Because of this one. Kaya gidagan man nimo ang 30 degrees padulong dito sa y-axis. You can actually use sa x-axis pero you have to be consistent. Kaya pwede man sad diri nga side. So you use 60 degrees. 60 degrees measured from there. And that means you should also be contain lang yung muhana. Kanang angle and so on. Yung gamiton. Kaya pwede man siya dire. Kaya pwede man ka makuha sine o cosine po dire.
Okay. So pwede ra dai didto. Pero mas sayon dari, sir. Unsa ba?
It's a matter of preference. Okay, ganahan mo ko sa y-axis. Pero basta ma-maintain lang nimo ang consistency. Kinsa imong WAX o kinsa imong WAY. Unsa nga angle.
Okay. Dili po siya maka-affect sa next nga free body diagram, sir, no? Kay lahi man siya.
Actually, dili man kay you're just trying to figure out unsa ang expression sa WAX o sa WAX.
Okay.
Pero if ang given is like given an angle theta, mas shorter siya kung theta ra pud imong gamiton. Kaya may tabuana is 90 minus theta ni siya dire. Kani siya dire na part. Kani siya dire is 90. Sorry. Minus theta. Let's say di ko maghatag. Well, di mo ko maghatag sa value. So 90 minus theta na siya every time na dire. For convenience, dire na lang ko magkuha. Para theta gyapon na siya.
Okay.
Mag 7 axis 90.
Okay. Copy, sir. Thank you po.
Other questions? Wala? Going once, going twice. Okay, let's move to the next example.
In this problem,
Sorry.
a lamp.
Okay. This problem is a static na problem na kay tulo ka strings na kay 60 degrees, 30 degrees. So, nasa like point of nag-connect siya at this Somerset T1. So, the lamp with a mass of 42.6 kilograms is hanging from a wire as shown in the figure. So, determine the tension T1 in the vertical wire, T2 and T3. Okay. So, with respect to the ceiling na horizontal, ang T2 is 60 degrees, ang T3 is 30 degrees with respect to that. So again, we look at the free body diagram. The first is ang sa weight. Weight ni mo ha, ang counter niya is ang T1 lang. So, ang T1 ni mo is upward, ang weight ni mo is of course going downward. So FBD niya is looks like this. Then another FBD is at the intersection or at point A. It's this one. Ba't nga lang pareho na ako color? Should be lang ako. Sige lang. It's this one here. This one now is this one. So ang T1 ni Moha is pulling downward. Then you have your T2 and T3. Your T2 is 60 degrees diri. So by kapangit pa sa straight line. Sorry class. Okay. How do I do this? Okay, kung 60 degrees dire, by angles, kani po siya is 60 degrees. Kung 30 ni, 30 degrees po siya dire. If you have a parallel nga line with respect to this one, okay? So, looking at T2 nasa sa x or y axis but it is on, kung ang Cartesian coordinate diri nasa sa second quarter. Ang T3 nimo nasa sa first quarter. Ang T2 nimo na diri so na siya T2y. Sorry class. Na kay T2y pataas o T2x padulong sa left. Okay, and this is 60 degrees. And then you have the T3. Ang T3 nimo ha, so in the first quadrant, so ang imong T3x is padulong dito, ang T3y padsaka. And this is 30 degrees. So now you have the components. And you can now directly sum mga components niya or write an expression. So for M2, for M equal to 42.6 kilograms, ang sum of forces along X is 0 using the free body diagram, pero ang imuhang Fy is tension 1 minus weight is equal to 0 kay static man siya, wala motion. So simply transposing the weight, which is just mg, so your T1 can be solved as 417.48 newtons. So there's lang class, Okay, guys. Sorry, I'm back. Yeah. So we look at ang T2 o T3. So if you look at ang forces, sum of forces along X, you have negative T2X. Ganun siya, kaya going mo siya padulong sa left. Then positive T3X going to the right siya. Okay, so, and we know by trigonometric function, ang T2X is T2 cosine of theta 2. Okay, along X and some, if you have here, sa cosine function. Ang T3X is again a cosine function, okay? X-axis mo siya. Okay, so transposing one to one side, and you are left with this expression here. Of course, hindi pa siya masolve kaya T2 and T3 are both unknown. So let's look at the forces along the y-axis. So T2y's and T3y are going upward, so positive siya. Going downward is ang T1. So again, applying trigonometric function, ang T2y is sine theta 2, ang T3y is sine theta 3. Negative T1. Transpose, so it becomes positive here. So this, you now have two expressions here. Again, so two unknowns ni siya. So, but we have two equations with two unknowns. So, this is within the realm of possibility na masolve siya. So, using this one, this expression here, ang imuhang T2 cosine theta 2 is equal to T3 cosine theta 3. And this expression, the second expression here, T2 sine theta 2 plus T3 sine theta 3 equal to T1. Itong nasolve nato earlier na value sa T1. Okay? So, rewriting ang imuhang this expression to this, so transpose ni muha ang no, not transpose. Divide this one by cosine theta 2 by crossing, so you get this expression here. And the other one is you divide it by, or not divided, but you substitute ang value sa T2 here. So, ang T2 ni Moha is T3 cosine theta 3 over cosine theta 2. Hence, you have this expression. So, this expression now is isa na lang ang ang T3 na lang. Okay? So, T3. What do we do? So, you have, we divide the function by cosine or factor out. What is this? What did we do? Yeah. Yeah. Sorry. Sine theta 2 divided by cosine theta 2 gives you a tangent function theta 2. So cosine theta 3, then this becomes a tangent theta 2. This one is sine theta 3. Then what we did is that we multiply by cosine theta 3, so that this is simplified to sine theta 3 divided by cosine theta 3. And this one will cancel out with this one. So tangent theta 2 ni siya o tangent theta 3. But this one, ang T1 is now T1 over cosine theta 3. So this is now the expression. Then what do we do is that we write an expression for T3. So we bring this one down, we cross that one here. So you have T3 is equal to T1 over tangent theta 2 plus tangent theta 3 cosine theta 3. Then we substitute the values. 60, 30 here, and here. O ang imong theta 3, 30. Then you have the 417.48 here. So ang T1 ni Muha, after you do the calculation, gives you 207.5 newtons. So we're done with T1 and T3. So that means solvable na kayo ang imong T2. Because you can go back to this expression sa imuhang T2, and rewriting that one, you get this expression here. Then substituting ang T3 na value na obtain nato earlier, then theta 3 is just 30 and theta 2 is just 60. And if you write that one, substitute that one, you get the value of T2 equal to 360.2 10 newtons. Okay, so that's it. So we're able to solve T1, T2, and T3 by algebraic means. Okay. Just kidding. Okay. So, any questions? Hello? No questions?
Sir, pwede mangayo anang slide sa example, sir.
Hello, nada may bayad. I'm just kidding.
Para i-review na mo, sir.
Oh, sure, no problem. No problem.
Thank you po.
Okay. Stop. Wala na yung question, class? Before I stop recording? Anyone? Okay. Stop sa recording so that I can give you this recording later.